right, so here's the answers that we should have for example 1. I'll give you a moment to look at them. Some things that I want to point out here. Working through the problems with f, that's totally fine. Notice that f of 2 equals 8. When we do the inverse function over here, f inverse of 8 equals 2. That does make sense. That means that this function has the point 2, 8, and this function has the point 8, 2, which it should if they are inverses of each other. Okay? The other thing I want you to pay attention to is this notation for the derivative of the inverse. We've got to be really careful with our parentheses right here. So if we want to find the derivative of the inverse, we write it like this: f inverse prime of x. So f inverse prime of x. And these parentheses around the f inverse are really helpful because if you don't put that prime and that -1 tend to get mixed up. Okay? So if we're going to find the derivative of the inverse of x, we just do the derivative of that function. We are given the function, and so since we have the function, we can just take the derivative of it. That's easy to do. So we do 1 over 3x to the 2/3, which, let's back up a little bit. We bring the 1/3 down, and then it's x, and then 1/3 subtracting 1 is -2/3, and so the negative exponent moves to the denominator. F inverse derivative of 8 is, we're just going to plug an 8 in. And just a quick reminder, when you are doing rational exponents, the bottom number is the root and the top number is the power. So this means we're going to take the cube root of 8, which is 2, and then we'll square it, which gives us 4. So 1 over 3 times 4 is 1/12. And hopefully what you notice is that the answers to C and F, those are reciprocals. That's going to come into play because when we need to find the derivative of the inverse, it starts out as a reciprocal of this other derivative over here. All right, let's keep going. So here's actually the formula for the derivative of the inverse. We've got all this conditional stuff. F is a function. It has to be differentiable. F has an inverse, and the inverse is differentiable. So what we get then is this formula for the derivative of the inverse. So the derivative of the inverse is 1 over, there's that reciprocal. So it's 1 over, it's the reciprocal of the derivative of the original function at the inverse. Okay, so it's 1 over the derivative of the function at the inverse. All right, let's look at actually how to derive this, and then we'll do several problems with it. So let's remember what we said about derivatives or functions and inverses. So if we have f and we have f inverse in here, right? If we do f of f inverse, we should end up with x as our answer. That's just a truth. So that's a actual true statement. That's the definition of two inverse functions. All right, so now we are going to take the derivative of both sides of this. Over here on the left, we've got chain rule. Our outside function is this blue function, and our inside, or our bubble gum, is the inverse function. So we're going to do chain rule. So we're going to do our derivative, right? F prime, F inverse stays the same. Then we're going to chain on the derivative of the inverse. So we got to do the derivative of the inside. So that's going to be F inverse derivative of x equals, and then the derivative of x is just 1. All right, so our goal right now is to figure out how to get F inverse prime of x by itself. So because it's being multiplied by this over here, we're just going to divide by that. So we end up getting F inverse prime of x equals 1 over f prime of f inverse of x. And that is where our formula comes from. It's the exact same formula that we have here. All right. Another thing to keep in mind is that sometimes, well, we'll do that on the next example. We're going to actually skip down and we're going to go all the way over here to example 5, and we'll start there on the next video.